My name is James Labocki. I'm the product manager for RHCI in the infrastructure team. I want to take you guys through a introduction to the OpenStack Foreman Installer. And feel free to ask questions as we go. I've got another screen up joined here. Um, so the agenda is basically this. We're going to go through a quick introduction so we can level set what's going on. We'll talk about some of the features of the Foreman OpenStack installer, and then we'll jump into the demonstration. So the demonstration is actually going to be a series of screenshots because the installation takes a long time, right? Obviously, installing RHEL on a whole bunch of systems would take too long. But I will provide a link to you guys that gives you a 5-minute fast-forward video of the installation happening as well. So, and then we'll talk about the roadmap for the installation, the Foreman installer for OpenStack. All right. So, quick introduction. I think I kind of use this every time I talk about anything in our infrastructure portfolio because I want to give you guys an idea of what our capabilities are in the private cloud. So, again, you see everything. This is what analysts and others are telling our customers they need when they want a private cloud. So you can see that all the things in blue are RHEL OpenStack Platform, RHEV, and Red Hat Storage provide. One of the things is that we don't provide with a RHEL OpenStack Platform necessarily is lifecycle management. So today we're including Foreman with OpenStack when we ship it. And so this is providing a means to install OpenStack, but it's not providing lifecycle management. And so certainly as we go forward, and I think if any of you were in the session on RHCI yesterday, you're going to see us start to bring satellite into the RHCI fold to bring lifecycle management to the story. So again, RHCI is that entire platform. We're going to focus on the OpenStack piece of RHCI today, the Red Hat Enterprise Linux OpenStack platform, and installing that. So real quick, just if you look at the latest numbers of OpenStack deployments that are out there today. So I went ahead and pulled the numbers from the latest OpenStack Summit, which took place in Atlanta in May. If you look at the number of compute nodes, so this is the number of compute nodes based on a survey, and the survey was done by the OpenStack Foundation, and it was a pretty good mix of OpenStack users across all geographies. If you want, you can pull up the slides and see exactly who some of the users surveyed were. But up here we have dev, and then we have POC for proof of concept, and then we have prod for production. And you can see the number of compute nodes that are in each of these, and you could see the deployment tool being used. So one of the interesting things here is that the number of compute nodes from 1 to 50 is the largest group across dev, proof of concept, and production. And the reason I think it's an interesting thing that they decided to make, the range of 1 to 50. I think if they would have made 1 to 5, you would have had a large amount of deployments in the 1 to 5 range. Maybe they did that purposefully. They don't want to show that the install base is still pretty small deployment size, right? But the other big thing that you can see here is that the deployment tool being used far and away is Puppet, right? So Puppet being used as a deployment tool in dev, in proof of concept, and in production. For example, 65 of the users surveyed were using it as a deployment tool in dev. The next closest thing was Chef with 32. So pretty telling that Puppet is being used very heavily to deploy OpenStack deployments. In fact, one of the larger OpenStack deployments by CERN, which I believe is about 7,000 nodes, is fully managed with Puppet. And they are also actually using Foreman as their Puppet orchestrator. So, all right. So before we jump into the OpenStack Foreman installer, I want to take you guys through kind of the evolution of OpenStack deployment tools. I'll make these slides available because it might be useful to go through with your customers or prospects or anybody that you want to kind of educate on what's going on in the OpenStack deployment tool space from a Red Hat perspective. So the first means that we had for deploying OpenStack was manual, right? So this is basically, what I was calling get out your reading glasses and typing gloves. So pull out all the docs and run through the command line of installing everything. This method is really great for learning. If you want to know how everything's configured, how you add new service endpoints in Keystone, how you create new volumes, all those sorts of things. It's great. It's bad for basically everything else, right? It's a total bear to configure everything manually. So along comes PackStack, and PackStack was a tool that we developed in the RDO community. And this is what I call get out your man page reading glasses and VI, right? So you're going to be hacking an answer file, and you're going to be reading every switch in the book on PackStack. So this is nice though, because we took it from just being command line to basically having some level of automation around a command line tool for deploying OpenStack. So this uses Puppet, right, in the back end to actually do the configuration. This is great for small deployments, like, for example, the PackStack all-in-one, right? I'm sure almost all of you, if you've installed OpenStack at Red Hat, you've probably used PackStack all-in-one at some point. The downside of this is it's not really robust, and it's kind of limited to OpenStack. So along comes Foreman. So next we took some of these Puppet modules that PackStack was already leveraging, and we were developing in conjunction with a lot of other people upstream. And we started to explore how we could use Foreman to basically deploy OpenStack. And so this is kind of what I say is, moving from, reading man pages to more point and click. The idea here is that you got to hope that you map the host groups in Foreman correctly for your OpenStack deployment. So this brought with it a web user interface and added also bare metal provisioning. So it took something that those are the two real improvements over the PackStack deployment, is that you could use this for bare metal provisioning and you had a web user interface. The other nice thing is that this took you beyond just deploying OpenStack, because what's really nice about that is, let's say I want to deploy OpenShift on top of OpenStack as part of my provisioning process. I could certainly grab the Puppet modules for OpenShift and begin to deploy OpenShift nodes on top of OpenShift instances on top of OpenStack and orchestrate that entire installation. So something that's really nice as we start to move into more complex deployments. So this is great for larger deployments, but it was still lacking. There were incomplete HA modules, and there was really no workflow or orchestration. So understanding what steps you had to take with Foreman, was largely kind of undocumented, and even if it was documented, it was not user-friendly. So finally, what we're going to kind of dive into today is this OpenStack Foreman installer. So this is the term I use here is, well, that was easy, right? Albeit it is a bit restrictive. So we have kind of a prescriptive guidance that we're giving with the OpenStack Foreman installer, but it really kind of at this point locks you into a specific architecture that you can deploy. And so we'll talk about the roadmap in the future and how we hope to change that. Any questions so far on the? I'll take them as we go. Might help. I hope this is useful for you guys. All right. So the truth behind all of this, though, is that choosing an OpenStack deployment tool is really not an evolution, right? So it's not that your end goal is to always use the OpenStack Foreman installation tool necessarily. It really comes down to the fact that what you're doing. So, if you want to learn how to deploy OpenStack, then the manual installation is the best way to do that. If you're looking to automate simple deployments, PackStack is really the answer. If you're looking to have complex deployment, that's really where you can begin using Foreman, or if you're having complex deployments that involve things outside of OpenStack. And then finally, if you're looking to actually make that simple and have a wizard-driven interface, that's where the OpenStack Foreman installation tool comes in. Yeah, Richard says, could you detail a bit about Staypuft? So Staypuft is the project name. The actual official product name is actually the OpenStack Foreman installer. So what you see here on the right-hand side, the OpenStack Foreman installer, that is Project Staypuft. So I'm going to refer to it as that. We've been calling it Staypuft internally a lot, but we want to make sure we don't want to bring the project name out to the customers, right? So what is the OpenStack Foreman installer? Well, it is a plugin that's built on top of Foreman. So Foreman has a plugin architecture that was included in it that you could basically add functionality to Foreman in a modular fashion. And that's what we're doing with the OpenStack Foreman Installer. It leverages Foreman's capabilities, so things like host groups and bare metal discovery, and all the smart proxy functionality can be leveraged through the plugin architecture. And it is designed to specifically deploy OpenStack. So it provides a user interface for the OpenStack deployment. This is completely new screens. This is not something that is just a workflow between what's already existing in Foreman. It provides deployment orchestration, so it will it will understand what needs to be deployed and in what order. It provides auto discovery of bare metal hosts, so we can actually do discovery of these bare metal systems, and it provides reference implementations for deployment. So it provides topologies for this. I see. So Richard, you were asking why the name Staypuft. Yes. It was so in one of the producers of a famous 1980s movie called Ghostbusters was passed away, and so the name was chosen based on that. And now we all have to live with it. So all right, so let's talk about some of the features of the OpenStack Foreman Installer. So there's some of the general features. So it's a simplified installation and setup provisioning tool. So we'll talk about how it's delivered. It provides automatic discovery of physical systems, like we had mentioned earlier. It also provides staged deployments. So you'll see how you can actually assign different hosts to different roles through host groups and actually then press a deployment button and actually kick this thing off. And it provides high availability deployments as well. So we'll go through some of the architectures that it allows you to deploy. So how's it delivered? Well, it's going to be delivered as a RHEL-based live CD, and it's basically going to offer the choice of either choosing a PackStack all-in-one install or a Foreman multi-machine deployment. So this is the goal we're going to get to. You can run Foreman from the live CD itself, or you can install it on that host. So you can actually boot the live CD, which will have Foreman on it, and then you can install it to the hard drive and have that persist. It runs on RHEL 6. With regards to discovery, how this works is the Foreman live image, or whether you're running the live image or you've installed it, exposes a Pixie boot environment, and then the hosts that you boot on that network would essentially boot the RHEV-based Foreman auto discovery image. So Foreman ships a discovery image that would boot up from the TFTP server, and then basically reports all the facts back to the Foreman database. So I can take an entire rack of servers, Pixie boot them all, then they show up inside of the Foreman database with all their facts registered. So this would be things like IP address, CPU type, all the things you'd expect to get back from Puppet. Once you have that, you could then assign the host to a particular role, and those roles are based on the host groups in Foreman, and they are those host groups are basically laid out based on what architecture you select you want to deploy when you create a new OpenStack deployment. So once you then initiate the deployment, Foreman then provisions RHEL 6 or RHEL 7 on those bare metal systems, and then subsequently runs Puppet upon the completion of the installation to go ahead and configure the systems to run whatever services are necessary for their particular role. Support for pre-provisioned host is coming in the next release. I believe there's a way to make that work already, but the support of taking an already deployed RHEL 6.5 or RHEL 7 system and then just assigning the host groups is coming as well. So the installation UI. So basically what happens is the OpenStack Foreman Installer drops an additional Rails engine, which then generates a new piece of the UI inside of Foreman and generates all the host groups required to configure systems for their roles within an OpenStack deployment. If you're familiar with the Wicked gem, it's basically using that to drive the wizards. The parameters in the UI as well for each of these host groups are inferred from the Puppet modules. So the Puppet modules that one of the things we're doing is we're trying to maintain. We're not trying to redevelop Puppet modules. We're trying to leverage the ones that are already being worked on upstream, I believe, in StackForge. So we're trying to leverage those. In the future, we actually want to have we actually want to include parameter metadata for relationship and control. So this would be you'll see today that when you enter in some of these variables, you'll enter them in perhaps in multiple places, multiple times, and we want to eliminate that. We also want to figure out relationships between them. So if I change it in one area, change a particular parameter in one area, it gets updated in the other areas as well, and kind of have those kind of things going on. All right, orchestration. So Dynflow is a workflow engine, Ruby on Rails workflow engine that the Foreman team uses for orchestration. So they've developed this basically kind of a state machine inside of Ruby on Rails, and it's for provisioning tasks and dependency resolution. So this is a Foreman add-on. It's going to ship actually in Satellite 6, and it allows you to order and build dependencies between tasks. It's very coarse-grained right now. So for example, if you wanted to deploy 10 hosts, that's going to be a serial operation, and it's coarse-grained. So in the future, they want to make that be able to parallelize those deployment tasks. If you were in the talk that I gave yesterday on RHCI update and roadmap, you'll note that basically the ability to have cross-product deployments out of Satellite 6 for RHCI is also going to push this as a requirement as well. So it's something we need to do across our portfolio. And then finally, in the future, they want to use Puppet SSH for concurrency and control of those hosts. So what do the topologies look like? There's essentially 4 OpenStack layouts supported. There's a non-HA and an HA layout. And there's both Nova Network and Neutron Network are the 4 OpenStack supported layouts. I'll dive into a couple of the diagrams here. They're not complete. They don't show Cinder, and they don't show Swift in all cases, or the entire topology. But it'll give you a good idea of what services are deployed on what hosts. So the HA deployment today is limited. The reason we say that is because all services need to be identical on the nodes you deploy. So in an HA deployment, you would deploy 3 nodes. This is so that you could do a kind of canary style rolling upgrade, taking an outage on one node while upgrading another and still having another one servicing requests. But the problem is today all the services across those 3 nodes must be identical. We'll talk about that in the future, what we want to do there. And Pacemaker and HA Proxy are basically providing the virtual IP addresses there. Future releases will kind of expand these reference implementations. So they're pretty simplistic today. They're not something necessarily that you would deploy in a customer outside of a POC style deployment. But the goal is to make these much more flexible and also much more expanded in the future. So in a non-HA, a non-highly available Nova deployment, this is essentially the services that would be deployed on both the controller and the compute node. You'd have on the left-hand side on your control node, or your Nova scheduler, whatever you want to kind of call this. You'd have Cinder, Glance, Horizon, Nova without compute, or Nova scheduler, if you will, Swift, and you'll notice Cupid. So we are using Cupid for the non-HA deployments in this case. And then you'd have on your compute node, Nova Compute and Kilometer Agent in this case. On a highly available Nova deployment, what will actually get deployed on each of the nodes is this. So you'd have, let's say, 3 controller nodes, and certainly you'd probably have multiple compute nodes as well. But the idea is today we deploy HA Proxy and Pacemaker to provide that the virtual IP addresses. And then you could see that we're actually we're deploying, I believe we're deploying Cupid as well here, let me double check that, but we might actually be deploying Rabbit today on that side. This is what's deployed here. You get Nova Scheduler on the controller nodes, and then Nova Compute on the compute nodes, and majority of the services. With a non-HA neutron deployment, you actually have the addition of a neutron networker node. So in a non-HA neutron deployment, you have a standalone host that's running the OBS agent, the DHCP, the L3, and metadata agents. And then the rest of the deployment looks very similar to the Nova deployment in this case. And then in the HA neutron deployment, this is actually different because the neutron networker node, those services, for example, the DHCP, the L3, the OBS agent, and the metadata agent, actually run on the controller node in that case. So again, these are pretty limited deployments. They're functional. You can get them up and running and working, but the idea is to make these, as we expand these, to make them more flexible. All right, so I want to take a few minutes to walk you through what this actually looks like as you go through a deployment. So I'm going to show you some screenshots because it's save some time and give you the basic idea, and then I'll give you guys a link to a video that you can watch that'll take you through this in a little bit faster pace. So the best way to kind of test this out, and let me just throw this out there, you might want to expand your screen by moving the slider all the way to the right or clicking the enter full screen button. So essentially, the best way to build out a sandbox environment if you want to test this out that I found was to actually deploy this on top of something like RHEV or something like libvirt to be able to do nested virtualization to test out the deployment. Not too many people have 5 to 7 to 10 systems to kind of deploy this on, so this is a good way to do this. So just to give you an example, here you see that I've deployed 5 systems. OpenStack 01 through OpenStack 05 are going to be my targeted OpenStack infrastructure. And then on the bottom there you see Staypuft 003. That's the OpenStack Foreman installer running the live image. So all of the OpenStack nodes, 01 through 05 in this case, are sitting on a private network. And you certainly may need multiple private networks if you want to actually deploy this correctly with public networks and Neutron and all those sorts of things as well. But I just wanted to see that the packages and configurations got deployed correctly, right? I wasn't actually going to launch tenants in this because with nested virtualization, I probably wouldn't be getting too good of performance anyway. Meanwhile, the Staypuft installer virtual machine you see down on the bottom, this is actually a multi-homed virtual machine, and it's actually acting as a Linux router. So I enabled IP forwarding on it so that any of the OpenStack nodes that I boot on a private network could route through the Foreman-based installer that acts as a Linux router and pull down the packages required to install both RHEL and OpenStack. So when you boot the OpenStack Foreman installer VM from a live image, you literally just attach the CD, drop an ISO onto it, and away you go. So this is a console of the OpenStack Foreman installer live image. So I've now booted off the ISO image, and when I get to the console, I open it up here, and this is what I'm going to see. Oh, by the way, keep in mind, I'm going to give you some dates at the end here that tell you when some of this stuff is releasing. This code here that I'm actually showing you is still pretty wet. There's a lot of QE still going on and those sorts of things. So if you see some funny things in here, it's because this isn't yet shipping with RHEL OpenStack platform today. So you can see that when I boot the live image here, I have a networking interface that it's asking me which networking interface I want to use. It's asking me for IP address, net mask information, gateways. So basically, it's asking you to go ahead and configure various options about this. And then once you go through and configure all these based on how you want to set this up, you then hit option number 1 to move on, and it will go ahead and configure Foreman for you. So it's taking a lot of the manual configuration of deploying Foreman and just making it kind of dirt simple. So you'll see here, I made a number of changes on the console. So I changed, the DHCP range, I think, the gateway and the DNS forwarder based on my network. So the gateway there was an external network that I had. So this is the gateway that the Foreman Foreman live image itself is going to use, and the DNS forwarder is a DNS forwarder that's going to give to all of the guests that it provisions as well. So that DNS forwarder has to be, you have to be able to get that through L3 connectivity from your private network. That's why you need the Linux routing, for example. You'll see then I hit number 1 and the installation takes place. That'll take a few minutes. There's some SE Linux stuff that runs as well, I think, in there. And once that's complete, it's then going to ask you for your subscription manager credentials. So it will actually subscribe your systems to subscription management as part of this process. So here you'll see I went through and set those values. One of the things that did not work for me is the RHEL repo path. So I think this is something that's being worked on now, where and perhaps it's just my lack of knowledge, but for whatever reason I couldn't get the RHEL repo path. I wasn't understanding why I wasn't able to set that automatically. So I went in and set that afterwards. I guess since it's not actually performing content mirroring here, you actually have to mirror that yourself and pull it down. So that's kind of another reason for why we would like to pull satellite in its entirety and not just Foreman, so that beyond Foreman we can also get content mirroring, which would be a real big differentiator for us in the deployment space, I think, of OpenStack. By the way, if you guys have feedback, I've got my other machine up here and I am watching the chat, so feel free to comment in there, or if you have opinions on various things in here, please put your feedback in. If you have ideas around how this can be made easier, or so on and so forth, I'm certainly going to grab all the information after this and take it back. Okay, so the web console. So once you actually install here, what you get to after the install happens is a web console. So you'll go here and you literally don't have to log in, right? You just log in, you're logged in as the admin already. And you'll notice that it looks a lot like Satellite. In fact, it's branded as Satellite here, but it doesn't have all the full functionality, so you can't create content views like Satellite 6 can and all those sorts of things. But you'll notice what happened is the OpenStack Foreman installer has dropped a new little tab in the menu called OpenStack Installer, and that's the addition of that Rails engine right there. So here you have, you'll notice that in this page, I actually already have my host discovered. I didn't get a clean screenshot, and I didn't feel like rebooting the live image, but basically your screen would be blank below here when you first boot it, but you can see where mine was at this point. So once that happens, you'll actually click on the OpenStack installer, and you'll select, you'll have an option to create a new installation. You can see I've already created a new deployment here, but if you didn't have one, you'd actually select new deployment, and what you would get is a screen that would guide you through your new OpenStack deployment. So here I have my deployment settings. So here's where I can enter a name and a description for my deployment. And down below for the deployment layout, you'll notice those 4 choices that we kind of went over the different topologies earlier. So I can do distributed with Nova networking, distributed with Neutron networking, distributed with high availability Nova networking, or distributed with high availability Neutron networking. Now, don't get thrown off by the term distributed. That just means that the packages that you're deploying multiple OpenStack nodes or controllers. That term always I always wondered about that. Why don't we just call it Nova networking, Neutron networking, and then HA Nova, HA. But I guess truly it is distributed, right? We are deploying on multiple hosts. Once you select next, you'll go to step 2. And this basically, what this is doing is it's basically telling you what services are going to be deployed on each host that you need for this deployment. So I have controller Nova, you'll see what's being deployed on there. You have a non-HA Cupid deployment. You have a Keystone, non-HA Keystone deployment, so on and so forth. Then it's also going to create an LVM block storage host group that is going to apply the Cinder services on it, and a Swift storage node with the Swift services running on it, as well as Nova Compute for a Nova Compute node. You select next, and this is where the services configuration happens. Now, this is actually where a lot of the meat of the pain in the OpenStack installation still exists today, and we're going to be working a lot to really improve this process. And so each one of those services in the left-hand tab, you'll notice you can select, and there's probably a dozen of them on the left-hand side that I cut off just for the sake of fitting it on the screen here. But when you select those services on the left, you basically get on the right-hand side, you get these configuration values. Like I said, these values in the text box there, those are inferred from the Puppet modules. So the Puppet modules that we're leveraging already provide values. So for example, if you were to select MySQL on the left-hand side instead of Ceilometer, it would provide default values for a MySQL setup that you could then go change. Today, there is no way to say relate some of the different configuration parameters with other ones and so on and so forth. And those are improvements that we're going to be making. All right, so once you have your deployment set up, so you hit the next button, now your deployment's ready. What you'll do is you'll actually pixie boot the remaining hosts that you have. So you'll go into those OpenStack 01 through 04 or 5 if you want to deploy multiple compute nodes, and you'll essentially go pixie boot those. Once those are pixie booted, if you opened up a console to them, you'll see I opened up the console to OpenStack 05 here, and basically you'll notice it booted the Foreman discovery image, and it says, it's giving me some interesting facts about the system, what it's booted, which is under product name, it says RHEV hypervisor, because that's the RHEV discovery image that Foreman provides. The MAC address, all those sorts of important things, right? And then it also tells you where it registered to. So in this case, it registered with my Foreman host, which is at livecd.example.com. So I didn't bother going through and trying to change all those values. I just went with them. So once you have booted those, in this example, I booted 2 of the 4 or 5 hosts that I'm going to deploy. I could then go back to my satellite UI, select hosts, and go to discovered hosts, and I can see them here. So you'll notice the name is actually based on the MAC address in this case, and it's discovered that they're on the default subnet, and when they were the facts of the system were last uploaded. At this point, once I boot all 4 of my hosts and I see them all as discovered, I could then go to my deployment and I can begin assigning my hosts to the host groups. So you'll see here on the left-hand side under host groups, we have controller Nova highlighted, and I can actually go to my hosts on the right-hand side and select one of my hosts, check the box by it, and assign it to that host group. Right? So at this point, what I've started to do is map the host to the role that I want to give it in my OpenStack deployment. Once I'm satisfied with how many hosts I've built and how many I've assigned, again, I'm just doing a non-HA Nova deployment in this simple example. I could then hit next and begin deploying. And what's going to happen here is, in a serial fashion, the Dyneflow workflow orchestration engine inside of Foreman is going to reboot each of the hosts automatically. So I don't have to actually go to the consoles and reboot, or go to RHEV and reboot them. It's actually going to reach out, reboot those nodes, and begin installing RHEL, in this case, RHEL 6 on them. So here in this example, you see that the host group controller Nova is 50% complete. And after that, it will install the LVM block storage host group, and it'll go through all the hosts that are mapped to that host group, and so on and so forth. So here you see the progress bar going on, so you'll see progress happening as this takes place, as it runs along here. Eventually, what you get to is your 4 hosts have deployed. So we have 100% done for our Nova controller node, 100% done for our LVM block storage, so on and so forth, and your deployment is complete. So what does this look like when it's done? Well, you can actually go to one of the nice things about Foreman is that it's going to actually let you start to see the status of your deployment. So once my deployment is complete, I can go back to the monitoring page, or the home page of Foreman, and I can see how each of these Puppet runs has executed. So I can see that here it's saying 60% of my hosts have deployed okay. I've deployed 5 hosts. I think I added another compute node after. And you'll see that 2 of them, it says hosts that had performed modifications without error. Those are basically systems that at that point were trying to start Swift and they were failing. I had made a configuration error. But the idea behind this is you can start to see all the, not only can you deploy your systems with this, but you can actually start to see drift as well. So this is going to become very valuable if somebody goes in and updates, a file. You can actually see that drift and remediate it through Foreman here. So again, going to the host status post deployment, you can see here that I have the hosts deployed, and it's telling me the A status here is an active status, and then it also shows you what host group it's mapped to. So here I have one mapped to the Swift storage node, one mapped to the LVM block storage, and so on and so forth. If I actually select any one of those hosts, I could then start drilling into a pretty substantial level of detail here. So some cool things here, you'll notice that I'm showing the log messages for the run on this host here, and you could see exactly what happened on the last run, all the messages that Puppet logged. Down on the bottom left, you can actually see the report metrics for this, right? And you can also see the report status. So this is a very Puppet-centric view of things, but it's showing you all the remediation. And in the bottom right, you can actually begin to see the performance. So I can actually, let me open it up in a different view here for you guys. I actually eliminated all the log messages so you can get a bigger view of this. But you can see on the bottom right-hand side, you can begin to see how long each one of these Puppet runs ran for and how long it took. So pretty nice metrics to be able to start to show even beyond just a deployment, how long things are taking to run and configure in your environment on an ongoing basis from Puppet. Yeah, Richard asked about should the controller node be installed before the compute node? Yes, so that is actually taken care of by Dynflow. So you'll notice, if I go back to here, if you look here under the output screen, under the output section, it's installing the controller first, and that is something that basically, that's the orchestration that Dynflow is providing. So as that matures, it will even get more intelligent about the idea is to make it more flexible and also more intelligent for dependency resolution, so that if you add more components to your OpenStack deployment, it understands you cannot deploy more compute nodes, for example, unless you have more Swift storage nodes. There's something along those lines, right, where you can just determine what's a dependency of deploying a compute node. All right, let me see here. So if you were to go to your controller and compute node after you deploy and just run an OpenStack status, this is basically, you can see my Swift service was dead here, but the idea is that you have your OpenStack deployments running, on both your controller and your compute node. All the services running, you can begin to utilize them. So with that, there's a demonstration video on YouTube, and I'm going to post these slides at the end. I'll give you a link to where you can grab these slides so that you don't have to write down this URL right now. But there's a demonstration video of an actual, I believe, a 7 or 8 node HA deployment, which is my Cinder service ended up continuing to break because of something I was kind of limited with in the lab. So you're better off just watching that video for the demo. All right, so let's talk about roadmap. So the dates essentially are this. In late June, RHEL OSP 5 based on RHEL 7 is going to be delivered. And the installation tool in late June is going to be PackStack based. So we're not going to ship the Foreman installer with RHEL OSP 5 until late July. So in late July, RHEL OSP 5 on RHEL 7 is going to ship with the Foreman installer with HA deployment plus PackStack. And then in late August is when RHEL OSP 5 on RHEL 6 with the Foreman installer for high availability and PackStack will be available. There's a lot of eyes on this right now at Red Hat. There's a lot of people working on it in QE and docs and all over the place, getting this thing ready. So those are the dates. So beyond those dates, what's next? So some of the things that we're working on are extensions for third parties. If, for example, a storage vendor such as NetApp or a network vendor such as Cisco wanted to include, functionality from their, let's say, a Neutron plugin, for say the N1 KV from Cisco. We want to be able to include that inside of the orchestrated deployments of this. Also with dynamic layouts. So today the layouts are pretty static. You can select from a kind of finite amount, but what we would like to do is be able to allow people to choose what to deploy onto each system and with some level of dependency and control. Also distributed high availability. So today when you select high availability, all the HA services run alongside the OpenStack services themselves. The idea is to be able to split that apart so you can run the HA services on other systems if you want, and then the OpenStack services on another. And even to allow for maybe I want 3 nodes to run my Ceilometer, services from a control standpoint, and then I want another 3 nodes to run, maybe some of the Nova scheduler from a high availability standpoint, being able to split those out and have distributed high availability. Something we want to move towards. Yes. So the question here we got. Sorry, pardon the question, as it may have been covered earlier. I may have missed a point. Was the installer the Foreman installer that would be shipped, or the Foreman installer was part of Satellite? The Foreman installer is not part of Satellite. The idea is that the 2 things: the Dyneflow workflow engine will be shipped as a plugin in Satellite 6. That is the workflow engine that the Staypuft project is using. So that's going to ship in Satellite 6, but Satellite 6 will not have the OpenStack Foreman installation plugin shipped with it out of the box. The OpenStack Foreman installation plugin is going to come with RHEL OSP 5 in late July and August only. So there's kind of a split right now. As I said, we're working out details of how to include in RHCI Satellite, and as part of that, I think one of the questions we're going to have to answer is how much of Satellite comes with a product. So there's some kind of things being worked out as far as a foundational Satellite being included with some of our products in the future. So hopefully you'll see some announcements in the next few weeks or months around that. I think from a packaging standpoint, those are details that are being worked out now. Yeah, Glenn, you're absolutely right. From a content mirroring standpoint, we certainly need it, and it would be a big differentiator for us. So I will definitely take that feedback. The live ISO image is based on RHEL 6, not Fedora today. All right, so a couple of other things on the what's next side. The expansion of the Foreman plugin for common installation. So if you were in the session yesterday, this plugin architecture in Foreman is very interesting and it's very differentiating. We have an opportunity as a company that has a strong offering in OpenStack, but also strong offerings in many other areas. We have a unique opportunity to be able to start to provide a common installation experience between all these. So we're kind of going to be expanding the Foreman plugin for common installation beyond just OpenStack. And the association of Foreman and Satellite with the OOO project for OpenStack deployments is something that will also be worked on. So as OOO matures and exposes APIs, the approach will be to still leverage Foreman for portfolio level installation. If someone wants to deploy, let's say, Red Hat Enterprise Virtualization alongside with OpenStack, alongside with CloudForms, they could use Foreman to do this, and Foreman would then basically call down into OOO to orchestrate those deployments. So, all right, so staying in touch. So the best places to go, these are internal to Red Hat. There is a channel on IRC called hashtag Staypuft-users. And then also, please, if you pull down the code and you're using it, ask questions on ROS Tech. At this point, things are still in very much in QE and in documentation mode. So any patches or contributions or feedback are welcome. And last but certainly not least, let me see if I actually can bring this up here. I think slides. Should have posted while I was talking. Yeah, here they are. Okay, so if you go to allthingsopen.com, the slides are available here. So, and click on any advertisements so I can have a meaningful retirement in my old age. I was just kidding. So with that, I'll take any questions in the chat. Any comments, feedback? All right. Well, with that, I think I'll give you guys, 10 minutes before your next session, and I'm going to go to the Satellite 6 lab. Hopefully I see a bunch of you guys there. Thanks, everyone.